Welcome to this equations workshop. Now, some key information to start off. First of all, this is not really about teaching you science, I'm afraid. This is about getting you marks on an exam. Every one of you probably has to sit an exam. Therefore, we want to make sure we can get marks. And this is about making sure you get the marks that you absolutely need to be getting. It's aimed at all GCSE Physics or Trilogy Science students. I've taken all of the questions from low to medium demand questions from AQA Trilogy papers, which means that they're all questions that will come up on a foundation paper or in the first half of a higher tier paper. However, they're still relevant to students who are looking for the highest grades, because really we're looking at making sure you're not losing silly marks, okay? So finally, the key message here as well is that it's relevant for any year, but I will be talking about using equations where all of the equations are on the equation sheet. At the minute, that's 2023. If anyone sees this video after 2023, we don't know what's happening with the equation sheet beyond, but the chances are they'll probably won't give you them all after this year. So this is what the equation sheet will look like in 2023. You've got a front side and a back side to a page. All the equation sheets are here available. And these are the ones we need to be searching for in these questions. The first section of this is what we call I do. So I'm going to go through these problems. I want you to make some notes as we go through. I'm going to point out the key techniques, and I really want you to follow these key techniques when you look at some of the other questions later on. First one here, we're going to start out, okay? So this is one of the questions where the equation is physically given to you in the question. This is sort of early on in a foundation paper this happens. The equation is there given to you. All you need to do is take the numbers from the equation. So we've got the mass, which is 155. So we're going to say density equals 155 grams. That's your mass. And the volume of the piece of limestone is 62 centimeters cubed divided by 62. Now, I will point out here, normally we would convert grams into kilograms, and we'd have to do something with centimeters cubed as well. But the unit they're looking for is grams per centimeter cubed, so we're going to leave it in those units. We're not going to do any conversion because you've got the same units in the answer there, okay? Some people think you need to cube this number. You don't, okay? The cubed is just on the unit. The unit is centimeters cubed. We're not cubing 62 here, okay? So we're just going to do 155 divided by 62 on the calculator. No trying to do it in our heads or any crazy on the paper long division or anything. We're just going to do it on a calculator, and this is going to give us 2.5, and that's the answer we're going to put in. Easy enough. You don't need to know anything about physics to answer that question. You could just walk into the exam having never learned a physics lesson and put those numbers into that equation, and you're getting 2 marks here. Nice and easy. The second question, again, you don't need to know physics really to answer any of these questions. They're all marks that are available just for using a little bit of common sense. So this one's asking you literally write down an equation, okay? It's not even asking you to recall an equation or anything like that, because you're given them all on the equation sheet there, so you've just got to copy it straight over. So here, the one we're looking for, this is a little section of the equation sheet I've just put on this page. We're looking for this middle one here. Some people are tempted to write, save themselves a few seconds and write just the letters. I'm begging you, write the full words, okay? Just copy it straight over as it appears. Charge flow equals current times by time. Now, the reason I want you to write the full words here is because if you write the letters, you are at risk of losing a mark if you don't get it exactly right. If you wrote it exactly with the correct capitalization and everything, that's an uppercase Q equals uppercase, so capital I, times by a lowercase t, that's absolutely fine. You would get the marks for that. But if you wrote something like this, if you wrote Q equals I times by T with a capital T, very easy mistake to make. This is not correct. It's not a correct equation. And so many times I've marked papers where I'm just docking marks because people have not written the correct capitalization. So just save yourself the risk of losing a stupid mark, and just don't be lazy, write the full words. It'll take you 10 seconds longer and guarantees the mark there. Okay, now the next question is asking us to use that equation. There is a sneaky little unit in here, milliamps. Now 90% of the conversions you have to do in physics are from milli to a normal value, or from kilo to a normal value. If you're going from milli, you divide by 1000. If you're going from kilo, you times by 1000. There are other conversions, but most of them will fall into that. If you forget about the conversion, it's not the end of the world. You would still get 2 marks out of 3 if you didn't convert this value, or you convert it incorrectly, so long as you follow the steps I'm about to show and show your workings. Showing your workings is absolutely crucial. So what we're going to do here, I'm not getting a mark for physically writing the equation here, so I'm not worried about writing the full words. I'm going to write Q equals I times by T. I'm going to leave myself some space between them because I'm going to write the numbers directly below. In this case, the current is 200 milliamps. As we've seen, we're going to have to divide that by 1000. So this is going to be 0.2 milliamps. 0.2 amps here. We're going to times that by 15. And again, I'm not going to do anything crazy like trying to work this out in my head. Okay, it's not that difficult a sum in particular, but we've got a calculator in the exam, so we're going to use it. So 0.2 times by 15 is 3, and this is 3 therefore. So like I said, you get a mark for just substituting the values in. You get a mark for doing the calculation, putting the numbers correctly into your calculator, and in this case there was the 3rd mark for doing the conversion to get 0.2. If you didn't do the conversion, you would get 2 marks, but only if you've shown your workings. If you don't show your workings and you get the wrong answer, you get 0 marks. So my answer here is 3. Okay, on to the next one. Okay, we've got another conversion that's needed here. 80 millimeters, we're going to divide by 1000. This is 0.08 meters. That's the first thing I see straight away. The next thing I'm going to do is we're going to look for the correct equations. We're looking for extension, spring constant, and elastic potential energy. Now there's a couple of equations here that have got spring constant and extension. You've got this one and you've got this one here, but the one we're looking for is this top one with elastic potential energy. So we're going to write the equation out here. So I'm going to write elastic potential energy equals, now half times k times e squared. I'm going to write 0.5 because that's how I'll type it into my calculator, times by k times by e squared. Very, very, very easy to miss the squared off here, okay? So you need to make sure you include that squared, okay? It's the sort of thing you need to look back and check when you're checking your answers at the end. So we're then going to put the numbers in. We're going to literally put them in directly below. So 0.5 times by 40 times by 0.08 squared, okay? Again, put it into your calculator, 0.5 times by 40 times 0.08 squared, and it's going to give us 0.128 joules. Again, you don't need to really know any physics. The only bit of this that is a little bit of knowledge is the conversion, okay, the 0.08. But if you didn't do the conversion, you're still getting 2 out of 3 if you've shown your workings, okay? If you've not shown your workings and you just typed it into your calculator, wrote the answer down, but you forgot to do the conversion, you're going to get yourself 0 marks, okay? Show your workings, you get a mark for just putting the numbers in there, you get a mark for doing the conversion, you get a mark for getting the correct answer, okay? Right, on to the next one. Now, this is a slightly different, slightly trickier style of question. This time they're looking for you to determine acceleration. We've got a time and we've got a velocity. Now, the interesting thing here is that they've not just given you the numbers in the text of the question, but you need to find them on a graph here. So they're looking for acceleration when we've got time and velocity. So this is the equation we want here, okay? So we're saying acceleration equals change, that triangle just means change in velocity divided by time. So it says between 0 and 1.6 seconds. So at this point is 0 and 0, and at 1.6 seconds if you, in your exam, I would suggest you draw this line with a ruler. It's difficult to use a ruler on a tablet here, so I'm just going to draw it by hand. But you've got a change in velocity from 0 to 4. That's a change of 4. Okay, so my change in velocity is 4, and a change in time from 0 to 1.6, which is 1.6 seconds. And if you do 4 divided by 1.6 on your calculator, you're going to get 2.5 meters per second squared. So it's a slightly different style of question where you've got to find numbers on a graph. But again, the equation is given to you, and you just got to look for those terms, find the right equation. The final one is of my I do section is a little bit trickier in that you need to rearrange this equation, but you do not need to rearrange it for question 6 here for the first part. So the first thing, we're going to find current, potential difference, and resistance, and you can see it on the equation sheet. It appears like this. Do not rearrange it yet. There's no credit for rearranging in this first one marker. Just copy it straight over. And again, I'm going to write it in full words. Potential difference equals current times by resistance. There's no credit for rearranging it here, and if you did try and rearrange it and you got it wrong, then you're losing yourself an easy mark, okay? Yes, you can write down any correct rearranged version, but just copy it straight over and use the word. You're just guaranteeing yourself marks that way. So the next thing, now again, in the next part, we're going to use that equation. So at this point, I don't care about writing the full word, so I'm just going to write V equals I times by R, as you see it over here. I'm going to put the numbers in. My potential difference of 1.68. I'm not rearranging it yet. 1.68. My current, okay, the current in a Y is 0.7, 0.7, and then the resistance is what I am trying to work out. Notice I have not rearranged it yet. All I've done, I've not done any physics, I've just copied numbers in, and I've got myself a mark. That's why I'm writing it in like that first, before I rearrange it. If you rearrange it first, and then you make a mistake in your rearranging, that means you've made a mistake in the first moment. It means you're going to get no marks from that point onwards. If you write your numbers in first, you've guaranteed yourself one of those 3 marks. Now I'm going to rearrange it. Some people use these equation triangles. Some people would just use the inverse operations to rearrange your equation. I'm going to use the inverse operation here, okay? And I'm going to say that 0.7 times by R. So to get the 0.7 on the other side, we need to divide by R to divide by 0.7 to remove it on the right hand side. And we're going to divide by 0.7 to add it to the other side. So we're going to end up with 1.68 divided by 0.7 equals R. And then again, no messing around with long division here. 1.68 on the calculator divided by 0.7 gives me 2.4. Okay, so my resistance here is 2.4 ohms. Like I said, you get a mark for just writing the numbers in exactly as they appear in the equation sheet, a mark for this, and then a mark for your answer. Notice that what I didn't do was just write 1.68 equals 0.7 times or something, you know. So I wrote R at the end because that's how it appears in a mark scheme. They want you to say where R is. They don't want you to just write this fraction. They want you to write that fraction equals resistance, because that's what gets you the credit. Okay, on to the we do section now. Okay, so those are your key skills. In this next section, what I suggest you do is pause it when I show you the question, have a go at the question, then I will go through it afterwards. If you don't have any idea how to start it, let me start it a little bit and then pause it and then have a go. It's up to you what point you want to pause. I've got 2 of these questions, so let's have a look at these now. So feel free to pause this here and have a go at this question now, and I'm now going to go through it. So this is one of those questions where you have the equations physically given to you in the question. This is about as hard as it gets because we've got a fraction and we've got a square root. But all you need to do is you need to use this button on your calculator, and inside that box you're going to press this button on your calculator, and then you can just put the numbers into the equation as it appears. So we're looking for the speed. It says calculate the speed. We've given the mass and we're given the kinetic energy. So I'm going to press the square root button on my calculator. I'm going to press my fraction button inside that square root button. I'll just use another colour so it's a bit clearer. So my number's at the top, 2 times the kinetic energy, so that's 2 times by 1,600. And on the bottom is the mass, which is 50. So again, we're going to type this into our calculator here. So we've done the square root, and it's 2 times by 1,600. And on the top and on the bottom is 50. And this is going to give us an answer for a speed of 8. Now, the unit, okay, of speed, this is one, hopefully we know this one is meters per second, okay? Unit speed is meters per second. If you do struggle with your units, there's an equation in the equation sheet that says speed equals distance over time, and the unit of distance is meters and the unit of time is seconds, so it's meters divided by seconds. That's your unit there, okay? So you can use that one to find the unit, but the equation that you are the equation you're using is given to you in the question there, okay? Next, we do question then, okay? So again, pause it here, have a go at this one. Okay, so this one, again, there's some conversions going on in here. Now, this question, the way that it works out, you can actually get away with it if you don't convert this one, because of the way that, because of the units they've given you, both of them are converted into kilojoules. You can actually leave them and they'll cancel out. But just for good practice, what we're going to do is we see kilojoules and we're going to convert it into joules. So 0.7 kilojoules is times by 1,000 is going to give us 700 joules, and 330 kilojoules per kilogram is going to give us 330,000 joules per kilogram. We don't change mass from kilograms. Mass is the only one that keeps its kilo. Everything else you get rid of the kilo. So now we can find the correct equation, which hopefully you have found. We're looking for the change in energy, we're looking for specific latent heat, and we're looking for mass. So it's this one down here. So again, I'm going to write the equation out as it appears in the equation sheet. E equals m times by L. I'm going to write the numbers in underneath before I do any kind of rearrangements. So my change in energy, that's the thermal energy that we're adding to the system here. So this is going to be 700 joules. The mass is what we don't know, and the specific latent heat is going to be 330,000. Again, I've now got myself a mark just for writing those numbers in under the equation as it appears in the equation sheet. Not done any physics there in particular. Next, we're going to rearrange this. Again, you can use an equation triangle if you want to. Okay. So to find m will be E over L. I'm going to use inverse operations because it's good practice. So 700, we've got mass times by 330,000, so we need to divide both sides by 330,000, okay? 330,000 there is going to give us mass. So we do this on a calculator, not messing around trying to do anything in our heads or long division. 700 divided by 330,000 is going to give me 0.0021, and it actually recurs. So 0.00212121, and it keeps going on. I would always write out in this situation that pretty much everything that's on your calculator screen I would write out in my working section there before I rearrange it, because before I round this. But because if you make a rounding error, you might lose a mark or something here, but there shouldn't be too much difficulty with this one. It doesn't ask us specifically for 2 significant figures or 3 significant figures here. I'm going to give 2 significant figures because that is what they have provided to us in the question. So I'm going to write 0.0021. However, I would actually suggest, if they don't ask you to round a question at GCSE level, if they don't ask you to round it, don't bother rounding it, because you can only lose a mark by doing something extra, really, okay? If you left this one as 0.00212121, that would be fine because they've not asked you to round it. Okay. So yeah, so that's your last of the we do questions. So the next section is the you do. So what I would suggest you do now is have a go at these questions yourself. Now I've written in the answers to these, so I'm going to go through them very quickly. I'm not going to write out all the answers as I talk here, but I will show you the answers afterwards. So again, pause on the questions that you're having a go at, and then I will show you the answers. So first one's here, so you can pause this, have a go at these ones. And then, sorry, and then the answers I'm going to show now. So these two are both just putting numbers straight into the equation that's provided in the question. It doesn't matter about the story they give you about an athlete. I'm only interested in the numbers here. So we put the numbers here directly below exactly as they appear and just type it into your calculator. So we should get these numbers. Nothing too crazy going on in this one. So the next one is question 12 here. Now in this case, again, have a go at these ones. I'll suggest you pause it and have a go. Okay, so I'm going to show the answers now. So in this case, again, the equation here I've written out, and you'll see that what I've done is I've written out the values directly below the equation before I've done any rearrangement. So I get 1 mark there for writing them out, 1 mark for rearranging it, and then 1 mark for the answer, and I get my 3 marks. Okay, please, please, please use this technique. Write the equation out, write the numbers below, substitute in, and then rearrange it. That's how the mark scheme is written, and it's written for that way because that's how they want to give you marks. I'm not telling you how to be a good scientist here today. I'm telling you how to get marks on an exam. Okay. The next one is just writing out an equation as it appears in the equation sheet, and then again, this last one on this page here, so question 14, is just putting numbers into that equation. There is a conversion. If you did not notice that you needed to convert minutes into seconds, then you would get 2 out of 3 if you showed your workings. If you didn't show your workings, you're getting 0 marks. If you did show your workings, you're getting 2 marks out of 3, so long as you've gone through this process. If you wrote 0.46 times by 2,500, and then the answer that comes up with, you get 2 marks, so long as you showed your workings. Didn't show your workings, you get 0. Okay? So very, very important there. And the last set of questions for this you do section. So again, I suggest pause here and have a go at these. Okay, I'm going to show the answers now. So in this case, what you want to be doing here is something like this. Again, you can see at the top here, you'll notice that these did not appear in the order they appear in the equation sheet, so I just write it exactly as it is in the equation sheet. No messing around with rearranging. Again, I get 1 mark for putting the numbers in directly below the equation. Just substitute those numbers in. 1 mark for rearranging it, and then a 3rd mark here for getting the correct answer. Please, 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 I've said this about 5 times. I make no apologies for repeating myself. Write the numbers out first under the equation exactly as it appears in the equation sheet before you rearrange. If you make a rearrangement error first, you will get 0 marks. The next one, again, I've written this out exactly as it appears in the equation sheet. I've not bothered trying to do the same order they've given me. I've just written it out exactly as it appears in the equation sheet. Resultant force is mass times acceleration. Again, I've put that same technique into place. I've put 1 mark for writing the numbers directly below the equation sheet. I'll repeat myself again. Do this step first before you rearrange your equation. My 2nd mark is for doing the rearrangement, and then my 3rd mark for getting the correct answer here. Okay? So my messages for you really are, make sure you're using that equation sheet. Everything is on there. Take your time and don't rush these questions where you're having to copy an equation out, and always substitute the values in before you do any rearranging. To finish off, I've put some extra questions on if anyone wants to just have another further go at them. So here are some extra questions for you to try. I'm not going to read through the answers to all of these, but I'm going to move over to the next slide in a second, which has got the answers, so you can pause and you can check any work against these in your own time, really. Okay, so here is some answers to those questions, and I hope this has been a useful workshop, and I just really hope that you take your time to not lose silly marks on these sorts of questions. Good luck, guys.